In the vast expanse of our planet's waters, life moves to a rhythm that seems alien to us. Beneath the shimmering surface of rivers, lakes, and oceans, a hidden world thrives. Here, every flick of a fin and every ripple in the current tells a story of survival, evolution, and adaptation. Among the most remarkable of these creatures are the fish, masters of a world that would suffocate most other forms of life. And yet, they breathe effortlessly, continuously, without ever taking a single gulp of air as we do. But how? How do fish breathe underwater? The secret lies in a delicate, intricate, and astonishingly efficient organ: the gills. Unlike our lungs, which extract oxygen from the air, gills are specialized structures designed to pull dissolved oxygen from water. To understand this, we must first grasp the challenge these creatures face. Water, dense and heavy, carries far less oxygen than air. While a breath of air might contain roughly 21% oxygen, the water surrounding a fish may contain less than 1% oxygen. Yet, fish have evolved to thrive in this thin veil of life-giving gas, using their gills to extract oxygen with incredible precision. The gills themselves are made up of thin, feathery filaments, each lined with countless microscopic lamellae. These lamellae increase the surface area of the gills dramatically, creating a vast interface between water and blood. It is here that the exchange occurs. Oxygen molecules pass from the water into the blood, while carbon dioxide, the waste product of respiration, moves out into the surrounding water. But the process is not as simple as mere diffusion. Fish use a mechanism known as countercurrent exchange, one of the most efficient systems found in nature. In this process, water flows over the gills in one direction, while blood within the gill filaments flows in the opposite direction. This opposing movement maintains a gradient of oxygen concentration along the entire length of the gill, allowing fish to extract nearly all the oxygen from the water that passes over them. It is a system of breathtaking efficiency, a natural design perfected over millions of years. To keep water moving over their gills, fish employ two primary strategies. Many species use a method called ram ventilation, in which they swim forward with their mouths open, forcing water to flow across the gill surfaces. This is why some large predators, like tuna and sharks, must keep moving constantly, even while they sleep, to survive. Others, however, use buccal pumping, a more stationary technique where the fish actively pumps water into its mouth and over its gills using movements of the jaw and throat. This allows fish to remain nearly motionless while still drawing oxygen from their environment. Yet, not all fish live in waters rich in oxygen. In warm, stagnant ponds or in muddy riverbeds, oxygen can be scarce and survival becomes a delicate balancing act. Some species have developed extraordinary adaptations. Take the labyrinth fish, for example. Found in the shallow waters of Southeast Asia, these fish possess a labyrinth organ, an auxiliary breathing structure that allows them to gulp air directly from the surface. In the Amazon, lungfish can even burrow into mud during dry seasons, breathing air through their primitive lungs until the waters return. Even in oxygen-rich environments, the act of breathing underwater comes at a cost. Extracting oxygen from water is far more energetically demanding than drawing it from air. Water is nearly 800 times denser than air, and moving it across the gills requires a constant effort. This is why fish have evolved streamlined bodies and powerful muscles, allowing them to cut through water with minimal resistance, conserving energy while they breathe. And yet, despite this complexity, fish are extraordinarily resilient. In a single gulp of water, a fish can extract enough oxygen to fuel the relentless demands of life underwater. It is a rhythm that has continued for hundreds of millions of years, long before humans ever walked the earth, a silent testament to nature's ingenuity. The marvel of gills extends beyond their function. They are also a window into evolution itself. Gills first appeared in the early ancestors of fish, some 500 million years ago, when life was beginning to explore the oceans in forms more complex than simple, single-celled organisms. Over eons, these early structures were refined, giving rise to the diverse array of fish we see today, From the tiny neon tetra that shimmers in the Amazon to the mighty whale shark that glides through the oceans like a living cathedral. Each carries the same fundamental design, each a testament to the power of adaptation. Breathing underwater is more than just a survival strategy. It shapes behavior, ecology, and even society in the aquatic world. Fish must balance the need for oxygen with the dangers that surround them. They avoid predators, chase prey, and migrate across vast distances, all while maintaining a steady flow of water across their gills. The invisible dance of water and blood within those filaments governs life and death in ways that are almost imperceptible to the human eye, yet it is as critical as the air we breathe. And so, next time you watch a school of fish shimmering in a sunlit river, consider the silent miracle taking place with every movement. Each flick of a fin, each opening of a mouth, is a delicate act of chemistry and physics, a testament to the extraordinary adaptations life can achieve. In the quiet of the deep, beneath the crashing waves and swirling currents, fish continue their eternal rhythm, breathing in a world that would leave us gasping, a world perfectly tuned to their needs. Fish do not breathe as we do. They have evolved a system that is uniquely suited to their environment, a design both simple and astonishingly complex. It is a reminder that life on Earth is diverse, resilient, and endlessly inventive. In the depths of rivers, lakes, and oceans, every gill filament tells a story of survival, of adaptation, and of the profound beauty of life itself. And as we look closer, we begin to understand that breathing underwater is not just a biological process, it is a symphony, a quiet, continuous marvel that has allowed fish to rule the waters for hundreds of millions of years. It is one of nature's oldest secrets, hidden in plain sight, waiting for those who dare to look